So thank you for coming in and getting settled today. I know I'm out of the classroom. Today we're going to continue solving systems of equations using substitution. And we're going to take a look at some similar problems to what we did yesterday, hopefully to help solidify things. But then also we're going to look at some unique situations as well before going on to solving some real world problems. No, seriously guys, can we put the cell phones and Snapchat away? Ha, got ya. Okay, so hopefully we're able to settle down, come back, focus on the problems. Steps today are the same as yesterday. We're looking at both equations, trying to solve for one variable in one equation. In this case, we're already solved for y or x, and so we're going to go ahead and substitute in for y. So wherever I see y, I know that y is x. So I can go ahead and say 5x equals 12. And at this point, we put in whatever y is equal to. Again, this is one of those unique situations, y equals x. So we have 5x equals 12x. We can go ahead and subtract 5x from both sides. And you get 0 equals 7x. When we divide by 7, if we have 0 divided by 7, x equals 0. So again, that's one of our ordered pairs. So over here we have 0. For the x value. Now I can go ahead and put in x is 0. So in this first equation, if we use that, we have y equals 0. And so this is, again, one of those unique situations where our ordered pair is the origin 0, 0. We didn't have an opportunity to see any of those yesterday. So as we study these next two problems, both of them would be relatively easy to work with. I guess I'd be inclined to work with the second one and just change that. So again, I'm going to solve for y and go ahead and subtract 2 from both sides so we get y equals x minus 2. So at this point, I'm going to go back to the top equation now, and wherever I see y, I'm going to put in the value that we found for y in the second equation. So we have 3x plus what we're going to substitute for y equals 6. In this case, we're putting in x minus 2. So now I can go ahead and combine like terms. 3x plus x is 4x. We end up with 4x minus 2 equals 6. At this point, we can add 2 to both sides, and we get 4x equals 8. So we can go ahead and divide by 4, divide by 4. We end up with x is equal to 2. So in our ordered pair, we now know the x value, or the x coordinate. We're going to go look for y. I can go ahead and put 2 into either equation. It doesn't matter. I'd probably be inclined to work with the top one. It looks pretty easy. Some of you may pick the bottom one, and that's okay too. 3 times 2 plus y equals 6. 6 plus y equals 6. So we can go ahead and subtract 6 from both sides, and you end up with y equals 0. So our coordinate at that point is 2, 0, and that would be the solution to these two equations. So here's another problem. I'd go ahead and ask you guys to hit pause, work with your table group for about 3-4 minutes, see what you come up with, and then come back and check your answers. So we should be resuming. If we notice the first one, we've got y already solved. It is equal to 7 minus x. So I can go ahead and put that into the second equation. So we're going to go 2x minus whatever y is equals 8. And so in this case, y is 7 minus x. Here's the one place people tend to get tripped up, is this negative sign gets distributed through to both terms. So I should end up with 2x minus 7 plus x equals 8. So just check your work, make sure you caught that one. 2x plus x is 3x. So we have 3x minus 7 equals 8. Add 7 to both sides. And we end up with 3x equals 15. You can divide by 3 and you'd end up with x equals 5. So again, in our ordered pair, we know that x is 5. And you don't always solve x first. That just happens to be what's happened so far. Now I'm going to go ahead and put 5 into one of the top two equations. Why not put it into the top? And you get y equals 7 minus the value we found for x, which happens to be 5. Go ahead and simplify, and we get y equals 2. So our second ordered pair is 2, so the answer to this problem is 5, 2. So this problem is an example of something that ends up a little bit odd. We end up with a statement that's true, 3 equals 3. And you're all going, yeah, we know that, Mr. Roth, don't need to tell us that. But if we take a look and we put in 3x plus 2, where we see y up above, we're going to get 6x minus 2 times all of y. That we found in the previous equation is 3x plus 2 equals negative 4. So go ahead and distribute through the 2, and we get negative 2, it's negative 6x minus 4 equals negative 4. At this point, when I go ahead and go 6x minus 6x, we get 0, and you end up with negative 4 equals negative 4. If I were to continue solving, I could go ahead and add 4 to both sides, and you might end up with 0 equals 0. Another alternative way that somebody might have taken this piece right here, so they might have added 4 right away, and they would get 6x minus 6x equals 0. And again, we're looking at a true statement of 0 equals 0. When we have that, our answer is infinitely many solutions, and we'd write that out. Again, if you want to use the infinite sign, feel free. The other option is, if we're looking at parallel lines, there's no solution to the system of equations. They're not going to overlap. Sometimes we can see that the slopes are identical right away, sometimes we don't. If we don't and we proceed through the whole problem, we end up with a false statement at the end. So in the example I have, 4 does not equal 7. So as we go through this, we're going to end up with a statement that's not true at the end. So wherever I see y, I put in 2x minus 3. So I'm starting with the top equation, 2x minus whatever y is going to equal 8. So we can take this y, plug it in there, and we get 2x minus 3. So I need to remember to distribute the negative sign through to both terms. When I do that, I get 2x minus 2x plus 3 equals 8. 2x minus 2x ends up being 0. So 0 plus 3 equals 8, and we know that 3 is not equal to 8. So in this case, we have no solution. And I don't need to go solve for the next variable because there's not one. So now we're taking a look at some real-world problems. This might bring back flashbacks to early in the year when we were doing weighted averages. There is another way to tackle those, and some of us might like it more, some might prefer the way we used earlier in the year. So the situation, a metal alloy is 25% copper. We have another metal alloy that's 50% copper. I'm trying to figure out how much of each alloy I need to use to make 1,000 grams of a metal alloy that is 45% copper. So in this situation, I'm calling the first alloy A. It's just how many grams of the 25% alloy we need. The 50% we're calling B. And when I add those together, we get 1,000 grams. So that is where this first equation down here came from. The next one is how many grams of copper. So it's 25%, so that's where the 0.25 came from, and I'm using alloy A. So it's 25% of the A plus 25% of the B is going to give us 45% the combined with 1,000 grams at the end. So I've run out of room on this page. I'm going to go ahead and flip over to the next one so that we have room to work with the two equations. And hopefully that doesn't give you too much of a headache as we put those together. I know that can be a stretch. Do the best you can on the assignment as you work through problems like that. So here we are. We've got our two. I would probably just simply solve for the top one and go A equals 1,000 minus B. So at this point, let me make that 1,000. So at this point, I'm going to put the 1,000 minus B in wherever I see A. So we get 0.25 times 1,000 minus B plus 0.50b equals, and I'm going to go ahead and do this, and I've already done it ahead of time on a calculator, and I got 450. Okay, so then we can go ahead and distribute through. 0.25, there's a decimal there, times 1,000 is 250. Okay, 0.25 times negative b is negative 0.25b plus 0.50b equals 450. Once we're here, we're just solving the equation. I can go ahead and combine the like terms here. Need to keep in mind that that's subtracting, so I have 0.25b left. I can subtract 250 from both sides. This is a river problem, so it equals 200. So at this point, we can go ahead and divide by 0.25, divide by 0.25, and alloy B, once I do the math and do this, I'm going to find that I have 800. And so that means we have 800 grams of alloy B. I can then go ahead and work with that first equation. I could work with the second one if I wanted to, but I choose not to. And I can go A plus 800 equals 1,000. When we take the 800 from both sides, we end up with alloy A, which happened to be the 25%, we end up with 200 grams. And I'm running out of space, so I'm not going to clean my answer up a whole lot, but we could go ahead and say we have 200 grams of the 25% alloy and 800 grams of the 50% alloy. When we total those, we have 1,000 grams. So here's a little different situation for the baseball fans out there. The New York Yankees and the Cincinnati Reds total have won 31 World Series. The New York Yankees have won 5.2 times as many as the Reds. How many World Series did each team win? So I'm going to use N for the New York, and I'm going to use this first set of information to make my first equation. Plus C for Cincinnati, so the wins New York has plus the wins Cincinnati has is 31 wins. So that's one equation. Then I come into this next series, and I have the Yankees have won 5.2 times as many as the Reds. So 5.2 C, so 5.2 times C, is going to be equal to the number of wins the Yankees have. At this point, we have our two equations, and it will take time, and I know that this can be a challenge, but I know we're able to do this. So 5.2C is going to go in this top equation where I have N. So I'm going to substitute at this point. 5.2C plus C equals 31. I can go ahead and add 5.2C plus 1C. That's going to be 6.2C equals 31. When I divide by 6.2, and again I did this ahead of time on a calculator to make it a little bit quicker, C is equal to 5. Once I know that, I just take it, I can put it into this top equation and go, well, what plus 5 is 31? N plus 5 is 31. Subtract 5 from both sides, and you end up with the Yankees at the time this was written had won 26 World Series. So the New York Yankees have 26 World Series, the Cincinnati Reds have 5. So this is what I'm asking you to do. It's 8 to 20 even, 35 to 39, and then 43 to 47 odds. Use the rest of class time to work on this. Please take your time, do your best. Tomorrow there is going to be a quiz, again looking at 5.1 and 5.2. And this is going to give me some feedback of, do we need to spend more time on these two topics, or are we able to move forward with other ways to solve systems of equations? Hope you guys had an awesome day, and look forward to seeing you guys all Monday. Talk to you later.